Alright, so when I saw you guys last time, I did open up 105 into Google Classroom, so I know some of you guys turned that in already, but if you did not, make sure your name is on it and come put it in the basket, please, if you didn't, so I can grade those and get them back to you today. And today will be our last new piece of information. Not really new to our class, but hopefully not new to you. So first day in this unit, we looked at section 1.1 stuff, which was linear functions, piecewise functions, slope-intercept, point slope, slope equation, vertical lines, horizontal lines, parallel lines, perpendicular lines, all that kind of stuff. And last time I saw you guys, we did quadratic solving with a heavy emphasis on quadratic formula, but we did talk about the other methods as well. And so then the last new piece of this, and that test date might be off, I need to double check that, is some quadratic function analysis, which is mostly about graphing quadratic functions. So we're going to go over the handout this morning, 106. It's pretty short, so we'll use this as a reteaching opportunity and a chance to answer any immediate questions. And then I have you practice like 15 questions or so in the book assignment. So that is the plan for today. So that puts us at, this is an A week, I believe. Is that correct? Okay. So I won't see you again until next Tuesday, but next Tuesday is ACT Aspire Day. So even though our class period is mostly normal, we will not be moving on to anything new that day. I don't have the schedule handy.
Do we have school at 4:21?
I'm sorry?
I don't think we have school next Friday.
Correct.
Isn't that 4:21?
Is that the test day up there? That's why I said I needed to check it again. But one thing, you guys should have the bell schedule for next Tuesday in your student announcements or your email, I think. So as always, they don't let us cancel 0 hour. The district just doesn't allow that. But for some reason, class starts at 7:35 on that day. So I have no idea why, but you're welcome to show up an extra 20 minutes later that day. Or you don't have to come at all if your parents are okay with calling you in like normal. Okay, so this will be the last new day today. I don't really see you on Tuesday. Or I see you on Tuesday, but we won't move on to anything new. So we will do a review next Thursday, which would put our test on Friday, which is what I have listed up there. But there's no school on Friday, which means your test is going to trickle down to the Tuesday after that. So I guess if anything, this gives you a bunch of time outside of class that you could chip away and make sure that you're well prepared for this next test. But I will go ahead and give out the review next Tuesday. I just won't ask you to, or won't require you to work on it until next Thursday. Okay, so this worksheet really has all the same questions with two different functions. So question 1 has one quadratic function. Question 2 just has a different quadratic function, but answering the same type of thing, so we can see a little bit of overlap. So this part can be kind of confusing, but this is what most people call standard form. But I think your book refers to this as general form. What we call vertex form is what your book calls standard form. Your book calls this standard form. Standard form can mean different things to different people, and it really just kind of depends on which textbook you look at or you're using. So I'm only pointing it out because when you do a couple book questions after this handout and you go to check your answers and it says put your answer in standard form, they're actually going to be putting it in vertex form. So for you to know if your answer is correct, you should also do vertex form. That's the only reason I'm pointing it out. So one thing that we need to be able to do is take what I call standard form and change it into vertex form and change it into factored form. And each one of these three forms are really the exact same line, but each one kind of has its own benefits. So like you really could find the y-intercept from any of them, But this standard form is really easy to work with because we know y-intercepts have an x value of 0. Plug in 0 for x here and here, you get 0 minus 12. So if all I ever really needed was the y-intercept, I would probably want to look at the standard form. Okay, jump over to factored form. It just kind of has different strengths. As its name implies, you should factor it. So it has a GCF. You should always factor out a GCF first if you can. Make sure that you check your answer with FOIL. If you need to not do guess and check and do product sum or something else, then please do. But to me, one of the strongest attributes of factored form is this, the x-intercepts. So we know x-intercepts are when y equals 0, and if it's already factored, we should be able to get those x-intercepts very quickly. Set each factor equal to 0 when solved, including this one. It's just that 2 doesn't equal 0, so that doesn't give us anything. X minus 3 equals 0 at 3, and x plus 2 equals 0 at negative 2. So if I needed x-intercepts, I would prefer to have factored form in front of me. Now, several of these others, vertex, is the vertex, what's the min and max of the function, where's the line of symmetry of the function, a lot of those really need this thing called vertex form. And from my experience, it seems like this is the one y'all practice the least in Algebra 2. So this is probably the part that you might need to put the most focus on. So first off, you need to know what vertex form looks like. It's kind of like a formula where it's got to be set up in the right structure. You have to know that A, H, and K are the three numbers that you should be plugging in. The only variables that should be here when we're done is X and Y. So you have to know where A comes from. Well, A is actually the same as this A. The reason why they use letter A is because it's the same A that we use in quadratic formula. So for our question here, A would be 2. So that's pretty easy to pick out. And then you need to know that if you paired up HK, this gives you the vertex, which is where it gets to name vertex form. So once I have numbers here, I can look at these two numbers and get the vertex basically right away. Now, there's two ways to find the x value of the vertex. I'll show you the other way in just a minute when we're done with our graph, but the most traditional way is this, because you're not always going to make a graph. H is negative b over 2a. Do y'all recognize that from anywhere? Besides just maybe seeing it in Algebra 2? Are you sure? What did we do last class?
It's like the beginning of the
Right, it's actually in the quadratic formula, it's this part of the quadratic formula, the far left part of the quadratic formula. Quadratic formula, this actually gets you the vertex, and then adding this scoots it over to get to the x-intercept, and subtracting this scoots it over to get to the other x-intercept. So it's really just the far left part of quadratic formula. Okay, so yesterday I messed this up 1 out of 3 times, so be careful with the arithmetic here. Opposite of b would be 2, divided by 2 times 2, which would be 4. 2 divided by 4 is 1/2. Now, if h is positive 1/2, this is confusing for students sometimes, make sure you're paying attention here. The form says subtract h, so if h is 1/2, it's supposed to say subtract 1/2. I'm not saying that the x value is negative 1/2, I'm actually saying it's positive 1/2. Okay, to find the y value of the vertex, just like you find any point, you have to plug in the x value into the function and solve for y. Just like any other point, this just happens to be one that we are interested in. So here we would get 2 times a fourth, which should be a half. Here we would get minus 1, and here we'd get minus 12. Negative 13 plus a half would be negative 12 and a half. So you find the y value of the vertex the same way you find any other point. Plug in x and solve for y. Okay, so standard form, vertex form, but this is what your book calls standard form. That's how important this form is. And then factored form. Standard or vertex form / vertex form is probably the one you need to actually look over a little bit. But the idea is, if you have it in vertex form, and you practice this a couple times, it's very quick to extract where the vertex is going to be. The vertex is the opposite of this, not opposite of that, because we subtract h but add k. So opposite of this would be 1/2, not opposite of this would be negative 12 and a half, or negative 25 halves if you want a fraction. Now, what a vertex is depending on if it opens upward or downwards, but what a vertex tells you is when the x value, you have a maximum value or a minimum value. So we already know that either the biggest point or the smallest point is negative 12 and a half. To know if it's a max or a min, you may not need to write this down, but obviously write this down if you don't remember this. If a is positive, like this one is, your parabola is going to open up, and your vertex down here would be a minimum. And in the next question, we will see when a is negative, your parabola has been reflected over the x-axis at some point, so his vertex is a maximum. Okay, let's go ahead and start to graph a couple of these points that we have on here. Notice if you center this graph too much, then the negative 12 and a half is not going to quite fit. So make your x-axis up a little bit higher. Yours doesn't have to be block for block the same as mine. Just make sure you give yourself a little bit more room down here. But let's plot the y-intercept to be negative 12. The vertex 1/2, negative 12 and a half. And our two x-intercepts that we have. Okay, so for part G, line of symmetry, this is also called axis of symmetry, maybe what your Algebra 2 teacher had called it. So parabola has this perfect line of symmetry. There's a line that's going to cut your parabola in exactly equal pieces. That line should always be a vertical line, so x equals a number, and it's going to always equal the x value of the vertex. For it to split the function or split your parabola exactly in half, it has to go through the vertex. So if the vertex has an x value of a half, we need this to be x equals 1/2. And I usually draw this in kind of as a faint dash line so I can kind of see that. So when it says I graph the function with 5 points from above, it looks like we only have 4 points, but because of this line of symmetry, any point here we can flip over and get a point over here. That doesn't really help us. But this point can flip over, and that gives us a 5th point. That's why they're referring to 5 points. So with 5 points and knowing what a parabola looks like, that is a pretty accurate graph. That is plenty good. Now, of course, not all of our questions that we're going to have is going to ask you to do so much with just one quadratic, but there is one really nice thing about answering so many things about the same one. If I had missed one or two of these things, something would feel wrong with my graph. Like, all of it needs to be consistent. All of the pieces need to fit in. Like if I thought the vertex went through 1/2, but I thought this x-intercept was actually 8, that wouldn't make sense. There's no way that this is the middle of the graph, but this x-intercept's way over here. Okay, so before we finish this up, I did say I had a second way you could find the x value of the vertex, and sometimes this is kind of a pain, which is why I still recommend you do the negative b over 2a. But look at, because of this symmetry, if this guy is at 3 and this guy is at negative 2, what's in the middle of those two? Yeah, 1/2. 1/2 is got to be directly in the middle. So that, if you know the x-intercepts, the x value of the vertex has to be exactly the average of those two. It has to be in the middle. So you can do that instead of negative b over 2a as well. Okay, the next couple of questions are the easier parts in my opinion. We do the same things in calculus, but in calculus we don't know what the graphs look like, but we try to describe with calculus where's the graph increasing, which is just a fancy way of saying when is it going up. And he starts going up when x is 1/2 and keeps going up forever to the right. Decreasing just means describe, bless you, where the graph is going down. Starts going down from the far left and keeps going down till he gets to x equals 1/2. And then constant means where's the graph flat, where does it have a slope of 0, and that doesn't apply here. Technically it does, it's technically 0 right here at this one instant, but we're not going to count that. Now one thing you may want to add to this is notice I didn't care how far down it went or how far up it went. What I cared about was when is it going up, when is it going down. So for these, make sure you're giving x values, not y values. We don't care what they're going up and down to, just when they're going up and down. Okay, so let's reset and do this all one more time with a different function. So some of it's going to work out differently, but like I said on the first one, if I just wanted y-intercept, I would probably use this, what I refer to as standard form. Your book calls it general form. Plug in 0 for x and solve for y. Since almost everything goes away, that's why that's so easy. Next I did x-intercepts, and for me x-intercepts are easy to get out of the factored form. So optional, but most people are going to want to factor out this negative. Set each factor equal to 0 and solve. -1 doesn't equal 0, so that doesn't give us 1. X equals 4 equals 0 at 4, and x plus 2 equals 0 at -2. I think there's once, maybe twice in the book assignment where you need x-intercepts and you can't factor. And of course, that would be quadratic formula. Quadratic formula is the only one that always works. Okay, for a lot of this other stuff, there's a couple things I could do here. The fact that a is negative tells me that this graph parabola is going to open down and the vertex is going to be a max. But really for most of the rest of these, I really want to look at vertex form. So again, vertex form, you have to know what your answer is supposed to look like. The most commonly forgotten thing to put on here, by the way, too, is the squared. If you don't put the exponent there, it's not a quadratic, so that's definitely wrong. You have to know where a comes from. A is the same as this a, -1. You have to find h, which is the x value of the vertex. And you can either do that by finding the average of the x-intercepts. Well, sometimes you don't have x-intercepts, so I guess you can't do that then. But let's see, the distance between these would be 6, so 3, so 1. Do y'all see how the number in between -2 and 4 would be 1? It would be 3 away from this and 3 away from this. That's one way you can do it. Or I still recommend that you use this as well. But take opposite of b over 2 times a and solve, you also get 1. So subtract 1 You subtract whatever the h value is, and then k, the y value of the vertex, you find by plugging in the x value of the vertex into the function and solve. Looks like that would be 10 minus 1, which would be 9. Opposite of this with not opposite of this gives you your vertex. The y value of the vertex is either the max point or the min point. That's the highest y value or the smallest y value, depending on which way it opens. My parabola could be cut in half and have perfect symmetry on the left and the right, but it's got to go through the x value of the vertex, so x equals 1. And then when we start throwing all of this on a graph, all of it should kind of make sense. If something is wrong in here, it should kind of stand out. It should feel very inconsistent with the other answers that we got. So let's go ahead and plot our 4 points. You don't really need to graph the line of symmetry, but the line of symmetry is going to give you a free 5th point without having to do any arithmetic. This point flipped over the line of symmetry gives you another point. That's not helpful because I already knew these two. But up here, this point flips over, and that's where the 5th point comes from. And 5, of course, more points is better, but 5 points is pretty accurate already. I didn't really need to go out of my way to find any additional points. Okay, increasing, decreasing, and constant would be asking you, when is the graph going up? Starts going up from the far left and keeps going up until x is 1. Decreasing is asking, when is the graph going down? Starts going down at 1 and goes down forever to the right. And constant would mean wherever your graph is flat. And technically there is, at x equals 1, it is constant at that instant, but we're really talking about intervals here, so we're going to say none on that. Okay, so this is a lot of information, and if this was the first time you had ever seen any of this, it would be way too much. But in Algebra 2, you probably spent, I don't know, a week or two doing all of this, but I realized you haven't used some of it in a year, so some of it's going to be kind of rusty, which is why we need to review it. But from this handout, before we shift over, is there anything that obviously stands out that you're uncomfortable with, or you know you're going to struggle with, that you want to ask some questions on? Okay. You guys remember 50% of it? More than that? 90%? Pretty close? Okay. Well, I hope it doesn't feel like a waste of class period, but all this stuff is good, especially for calculus and college algebra. Probably even more in college algebra, but okay. So you will need a textbook if you did not see the sign this morning, and I think you got about 15, 16 questions there. So if you go ahead and start on those. As usual, we'll check in 10 or 15 minutes to try to wrap up. If there's any issues with anything. But it should be short enough that you can do it without having to do it. It's been 11 minutes. So the first few that you've had time to try. Any of those giving you issues that you'd like me to work out on the board? Yeah.
Can you do number 17? I can't figure out how to find this. I don't know how to do this library formula.
Yes, because it doesn't look like it factors. Factoring would be my preferred method, but this just doesn't factor. So yeah, your only option then is to plug all of it in quadratic formula. Just like we did last time, be careful with this stuff under the radical. This is called the discriminant. 36 minus 8 would be 28. 28 should break down into 2 square root of 7. And then because every term is divisible by 2, looks like that should be your x-intercepts. Is there any other parts of this one you want us to go over? Okay. Okay, let me give you another 10-15 minutes. Of course, if you get to a question that you're completely stuck on, don't spend too long on it. Just move on and be ready to ask about it. Okay, it's time for a few more questions. Anything else you found? Yep.
Do you need to measure numbers for the x-intercepts?
Yeah, so if you solve a quadratic and your solutions are imaginary, they have I in them, they do not show up as x-intercepts. Imaginary solutions don't show up on the x-axis because we don't graph imaginary numbers.
Okay,
So that would tell you that they had no x-intercepts. Again, you guys shouldn't be using a calculator to get your answers here, but of course, once you answer the parts of the question you're supposed to answer, instead of just checking in the back of the book, you could graph it in the calculator and just see if your answers match up to their graph. Okay, that's it for now. Okay, I'll reset our timer. Yes.
On number 17, you did earlier, why? Oh, wait.
You figured it out? Okay. Because I didn't hear your question, so. Push. This way. Time to try again. It's been another 10 minutes. So, new questions you found, Julia?
How do you find like the constant for like there's like for like when you're writing standard form of vertex form what you call it?
Uh-huh.
How do you find the constant? Like the A?
The A,
Yeah. Like
this A is the same as this A when it's written like this. That's why they use the same letter.
So how do we do like number 39? How do you find it when you're using and a vertex?
Oh, I see. I see what you're saying. Yeah, in that case, you got to do something different. So, on question 39, let me see if I've got this yet. Okay, in question 39, they tell you the vertex is at 1, -2. So that's your H and your K. So you can plug 1 in for H, -2 in for K. Again, this looks opposite and this one does not look opposite, so don't let that throw you off. Also, don't forget the square here, because otherwise it's not a quadratic. But the other thing they give you in 39 that makes this possible is they give you one other random point, -114. So the last thing you really need is to substitute A with a number, but you don't know how big A is. But what you can do is you can take this point that they gave to you and temporarily plug in 14 for Y, -1 in for X. And what that's going to do is it's going to create an equation that only has A in it. So we can take a couple steps, solve that for A, and then we can go back up here and plug it in and have our answer. So this would be -2, but you square it, it becomes 4. Add the 2 over, divide both sides by 4. Looks like A would be 4. So plug that in, and then you should be finished. So vertex always goes in for HK, and if you need to solve for A, you might need to take another point, temporarily plug in X and Y so that you can solve for A, and then you have all your pieces. Okay, any other questions y'all have ready to go? Okay, I'm gonna set one more timer, but that will be the last chance to ask questions in class. Because we've got just under 20 minutes left, so give you a few more to get a couple more questions done, and then I need your questions that you may have so I have time to work them out.
if like the table only gives me like whole numbers?
If you do second trace, this is the stuff that is good at finding. So
Mhm.
x-intercept, sometimes called the 0. So pick that. Okay, before you hit enter, you need to move your cursor to the left of the x-intercept you're trying to find, because there could be more than one and it doesn't know what you want.
Like up here?
Oh, as long as it's to the left, hit enter. And, oh, no, you went too fast.
Oh.
You gotta do something different the second time. Okay, so enter for left bound. Then you have to move your cursor to the right of the x-intercept before you hit enter on right bound. And then you can hit enter again and skip goes.
Okay. Thank
And
you.
then it should take you to it. Now, if it's a really weird decimal, though, that means that you probably need to use quadratic formula, unless it asks you. is our last 10-minute timer, so it's your last chance to ask questions while you guys are here. Anything else that you're seeing?
Can you remember 73?
73? Sure. 73 used to be a pretty common question type, especially within like math contests and stuff. But basically someone has 200 feet of fencing and they want 2 separate pins, and of course they want to try to maximize the amount of space here, so they're trying to maximize area. So because this is well, if you look closely at the picture, they tell you that these lengths are X and this length is Y. But because we have a rectangle, area would be length times width, or in our case, length would be 2x and width would be y. The only thing wrong with this being your answer is it says it wants area, or at least for the first part, it wants area in terms of x, and right now it's in terms of x and in terms of y. But we can use this that has got 200 feet in fencing, so we've got 200 feet to play with, and how many x lengths do we have? What's this length? There's 4 x's. How many y lengths do we have?
2.
What's this length?
Same.
So it's 3. If you're trying to put that middle fence in there to like keep these animals separate or whatever, you need 3 y lengths. So what this does is allows us to solve for y. Subtract 4x over, divide both sides by 3, and then instead of saying y, we can say what y is equal to. 200 thirds minus 4 thirds x. So that is the answer to part A. That is the area formula in terms of x, not x and y. And then what dimensions would produce a maximum enclosed area? So basically they're saying if you've got this function, if you want to maximize it, maximums occur at a vertex. So it's just a real world application of what vertex would be. Now I guess you could distribute this and try to get it in a nice looking form and try to find the vertex by hand. But realistically I would probably just graph it, and I don't have it graphed anymore. But if you graph that function, you're going to see a parabola, find the maximum, and it will tell you the x value that you should have and what the maximum area should be. So I would do that with you, but we've got about 4 minutes of class, so if I start that I won't be able to finish it before we're dismissed. But are you okay with how to find the last part?
So I find the maximum.
If you're graphing area, the vertex represents the maximum. So the x is like 25 or something, I think, once you graph it. You're going to have to change the window settings for you to see the full parabola. You got to play with it enough that you can see the vertex at least. So x needs to go way further to the right, y needs to get way further up. But in that case, y represents area and x represents this length. So if you know that length, you should be able to get the dimensions.
I think I'm way far out.
Huh?
Like zoom out like a lot.
Well, if you look at this, x certainly has to be less than like 25 or 50, I guess.
I want to see like the vertex. Zoom out like 5 times.
Let me come look at what you got. right when you need to. So go back to your limit settings. And you're gonna need to do way more than that. Search window. So to see further to the right, you can change X max. But you're doing X max. I don't know, it's a little bit of a check. Try 50. Okay, get your out. And then we're gonna hope that we can see it going up and then maybe come back down somewhere. Otherwise, did we come down?
Yeah, but.
Okay, so your vertex is up here somewhere, it's doing it, so you need to go higher up on Y, so go to window again, and you're gonna change Y max. So make that something bigger. Very close. The vertex is gonna be the max area. Have a good day. This one to tell you when the max occurs by the right side. I think it's more like 1,000 or something. It's usually quicker to just pick up the big number. And then, see, you would waste a long time because you still can't quite see it, but you're pretty close. So maybe 2,000. It's usually easier to take away because okay, so now you need to find that maximum.
And that's that answer to the dimension.
Like that doesn't look like. Okay, you gotta do the maximum again. That. Okay, left bound, so your cursor needs to be to the left of your maximum before you hit enter. You did that. But then right bound, you need to move your cursor to the right. And you just kept hitting enter, so it was only looking at one value. So your maximum occurs when X is 25, it's got the little around there. And then that's what your max area would be. So that's asking for the max dimensions. So if X is 25, you know, this is gonna be 50 by whatever Y would be. But if you know X is 25, you can solve Y. Remember the equation earlier. Is that your last one?
$33.33.
33 and a third. So if you have 4 25s, that would be 100. And then if you have 3 33 and a thirds, that would be another 100. So there's your 200 feet of fencing. That sounds right. But it's just trying to show you an example of why you would care about vertex instead of just being something abstract.